Hello and welcome back to 8701. So in this class, we want to talk about the range of forces and specifically how the range of forces depend on the mass of the particle involved in transmitting the force. We have seen this table before, the different forces, the strong force, the electromagnetic force, and the weak force, and the boson which carries the force. Gluons, photons, and the W and the Z boson. But now we want to actually just look into the aspect of the range and how masses interplay here. So you all know the electromagnetic potential due to a point charge given by the Maxwell equation. So we have seen this equation before, and the time-independent potential here. You also know that the massless photon gives rise to an infinite range of the electromagnetic interaction. But the question now is, how would this change? How would this be modified if the photon were massive? So to do this, we have to generalize this a little bit. First of all, we have to look at the time-dependent equation or the wave equation. This is wave equation. We have also seen this before. Wave equation. And by adding a mass term. So we are using here an equation which has to be fulfilled by all particles. It's a relation between energy, momentum, and mass. We have discussed this in the context of special relativity before. What we are trying to do now is build a Schrödinger-like equation by using the quantum mechanical operators for energy and momentum. So we just add this here and find a new equation, which is called the Klein-Gordon equation. That's equation. So this equation has to be in all particle waves, all particles have to fulfill this equation. So the question is, what kind of solutions does this kind of equation have? How does this look like? And if you now, start from, again, a time-independent equation, you find solutions which look like this, right? And you see, again, very similar than to before, the charge over some constant as a function of radius, but you also see this exponential term. And what we see here, this potential, this form of potential is called Yukawa potential. And what's nicely shown in this plot here, this is again, the potential as a function of radius in units of femtometers, the dependency of the mass of the range of the force on the mass. So you see here as an example for the mass equal to 0, mass equal to 1 GeV and mass equal to 10 GeV, and you can easily see the range of the force is reduced by the fact that the particle actually had mass. Now, the gauge boson, the boson of the weak interaction, the W and the Z boson, are quite massive. They have masses in the order of 80, 90, or in the order of 100 GeV. So you can see that the masses actually leads to a reduction of the strength of the range of this force. And what we find here, just don't look at the gravitational part here. It's not part of the standard model. If you look at electromagnetic interaction where the range is infinite, we find that the range of the weak interaction is 10 to the minus 18 meters. So this is greatly reduced because of the masses of the particle. If we just look at the charge itself, you would find that the weak interaction and the electromagnetic interaction are actually quite comparable. We will also talk about the strong interaction. You see here for the strong interaction that the coupling, alpha, is in the order of 1. So when we talked about Feynman diagrams, we talked about perturbation theory. Now, if you do a perturbation series for a interactions of order of 1, couplings of order of 1, your vertices in the order of 1, you'll see that perturbation theory might break down. So, okay, so what we have seen in this lecture is how a mass or how masses reduce the range of a force. You have simply built a Klein-Gordon equation here, looked at a solution and found that there is this diminishing of the range of the force. Later, we will look at one additional complication, and another equation which has to be fulfilled by particles, which is so-called Dirac equation, which has to be fulfilled or held up by fermions. But that's beyond of the scope of this class. We look at this later in more detail.